Welcome to dancnet.com, the CCIE troubleshooting blog. In this screencast, we will walk through ticket number 6. Let's start by reviewing the topology. As you can see, the major network is 5.11.x.y, and loopbacks are usually 5.11.y.y/32. But we should notice that R1 and R4 got additional loopbacks. R1 got loopback 11 and R4 got loopback 44. Now let's review the IGP topology. As we can see, the whole network is included in ERGRP process number 11. No interfaces are excluded from this routing process. And now to the problem. R2 can ping to R1's loopback 11 and R4's loopback 44 from all of its interface. Here is R2, and here is R1 and R4. We are told that R2 cannot ping to both loopback 11 and loopback 44 from all of its interfaces. What are R2's interfaces? It's fast 0/0 and it's loopback 0. Now, let's try to ping to R1's loopback 11 and R4's loopback 44 from all of R2's interfaces. As we can see, it's not working from R2's loopback 0. Since it's working from R2's fast 00, we know that we do have a route to R1's loopback 11 and R4's loopback 44. Maybe R1 and R4 got no route back to R2's loopback 0. Let's check it out. We do have a route back from R1. Let's check R4. We do have a route from R4 to R2's loopback 0. Let's move closer to R1 and R4 from R2's perspective by reviewing R3 routing table, looking for entries for R4's loopback 44 and R1's loopback 11. When we look at R1's loopback 11, we see a route of 10.0.0/8 route, and it's pointing to R4 and to R1. We see the same thing for R4's loopback 44, a 10.0.0.0/8 route, pointing at R4 and at R1. Why do we see such a route? Why do we see a 10.0.0.0/8 route? Let's have a look at R1's ERGRP configuration. We see that auto summary is not disabled. That's why R1 sends a 10.0.0.0/8 route. Let's have a look at R4's ERGRP configuration. Same problem here, like R1. That's the reason why R4 sends a 10.0.0.0/8 route. Let's have a closer look at how auto summary works. R1 got two major networks, 10.0.0.0 and 5.0.0.0. When auto summary is enabled and a route crosses a major node boundary, ERGRP will send a 10.0.0.0/8 route. But when it doesn't cross, like R1's loopback, no summary is happening. So R1 sends /511.1.1/32 route to R3. On R3, we should see a /32 route for R1's loopback 0. Let's check it out. We do see a /32 route for R1's loopback 0, and it's pointing, of course, to the right direction. Before we fix the problem, we need to explain why some of the packets from R2 do reach R1's loopback 11 and R4's loopback 44, while others do not. Let's see how R3's Ceph will switch R2's packet. Oh, sorry. We can see that when the packets are originated from R2's fast00 interface, the next hop is the correct one. But when we source it from R2's loopback 0, we see that it goes to the wrong direction, to R4. It's not documented how Ceph will choose the next hop, but we do know that the source IP address is part of the hash calculation. Let's fix ERGRP on both R1 and R4 and see the routing table entries on R3's routing table. Now everything looks good. We have a separate /32 routes for both R1's loopback 11 pointing to R1 and R4's loopback 44 a /32 route pointing to R4. Let's try again to ping from R2 to R1's loopback 11 and R4's loopback 44 from all of R2's interfaces. Success! Thank you for watching this screencast. Please leave your feedback at dansnet.com. Enjoy your studies. Bye bye.